Okay, so this is a video for people who should have some experience with an insertion sort. Just to recap how insertion sort works. It's similar to a bubble sort, but more efficient. Why is it more efficient? Well, let's take a look at this. We're going to sort it out in order of smallest to largest. It's going to start on here to begin with. This is going to be our first item. It's then going to compare this against the item before it. Is 6 bigger than 5? Yes it is, so it's going to switch. It's then going to look at number 3. It's going to compare number 3 with number 6. Is it bigger? Yes, 6 is bigger than 3, so it's going to go 5, 3, 6, 1, 8, 7, 2, 4. It's then going to look at 3, compare it with 5, and do another switch because 5 is bigger than 3. On the next iteration, it'll be on 1. 1 will compare with 6, there needs to be a swap. On the next iteration, 1 to 5, there'll be a swap. On the next, 1 with 3, and so on. This is different to a bubble sort, where a bubble sort, the way it works, is if we were to use this, it will compare 5 to 6 and do a swap. So this is what it'll look like after the swap. But it won't then, in fact, let's just play this forward a little bit more. The starting point would be actually here as well on the bubble sort. It'll compare this with the one next to it. Whereas an insertion sort started here and checked backwards. So it'll say, is 6 bigger than 5? Well, is 5 smaller than 6? Yes it is, so let's do our swap. In our loop, it'll then be here. So, here now. It'll compare 6 to 3. It'll do a swap. It'll then be here. It'll compare 6 to 1. It'll then do a swap. But what do you notice about these numbers? These aren't sorted out yet. So it's going to keep moving this along, but it'll still be unordered. Whereas an insertion sort, the way it works, it compares 5 with 6, there's a swap. It then looks at, so let's just do this. It then looks at 3 to 6, and there's a swap. But then it looks at 3 to 5, and it swaps it again. Once it gets to here, it finishes, and it moves on to the next number. Whereas, with a bubble sort, once it does one swap, which would be switching 6 with 3, it would leave 3 here, even though 3 should be here by the end of it, and it will start doing 6 with 1. So it'll be 5, 3, 1, 6. The problem with that, as we said, is that with a bubble sort, it leaves these numbers unsorted. It will go round again and again and again until they're all organized, but that takes a lot of time. So let's have a look at how an insertion sort actually works with the pseudocode from what our exam board, CIE, provides us. So this is called, we'll go call this name list. So this is our list. We're going to start on number 2. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go 2 to 8. We're going to take our number 5 and put it into a variable called temp. So temp is going to have the number 5 built into it. Then what we're going to do is we're going to have a variable called pointer, and that's going to be equal to this pointer, which is 2 minus 1. We're then going to loop through this. While name this pointer, which is name this pointer is value 1. So this is larger than temp. So 6 is larger than 5. So temp is 5, remember. And pointer is greater than 0. Yes, that is true. We're going to take name this pointer, which is 6, and put it into name this pointer plus 1, which is going to be here. Pointer is 1 plus 1 is 2. Remember, pseudocode, it goes like this: 1, 2, 3, 4, 5, 6, 7, 8. So it's going to put into position 2 for number 6. I'm going to make this pen a bit thicker. So 6 goes in here. Let's make it a bit more thicker. Okay, so that's 6. We're then going to decrement pointer by 1. So pointer is now going to be on 0. It then loops again. While name this pointer, which is 0. Well, we can't do that, there's no 0, and pointer is greater than, well, it's not greater than 0. As it's not greater than 0, we're going to end this while loop. So we've got so far, let me just make this a bit neater. 6, 6, 3, 1, 8, 7, 2, 4. 5 is gone, but 5, remember, is in temp. So we're going to put temp into name this pointer plus 1. Pointer is 0, so we're now going to put 5 into here. So we've got 5, 6, 3, 1, 8, 7, 2, 4. This pointer goes up by 1, so we're now on 3. So we're dealing with this number here, which we're then going to put the value into temp, which is 3. Inside 3 is 3. We're then going to get this pointer, which is 3, take away 1, which is now 2. So this is basically, I want you to loop backwards 2 times. While name this pointer, which is 6, is greater than temp 3, well it is, we're then going to put 6 into here. We're then going to take away 1 from pointer. We're then going to loop again. Name this pointer, which is now going to be 6 at the moment. Is it greater than, sorry, no, it's not, it's 5, I'm an idiot. Pointer is 1, we're now here, aren't we? So 5, is it greater than temp? Yes, it is. Is pointer greater than 0? Yes, it is. So what we're going to do, we're going to put the 5 and put it into name this pointer plus 1. So we're going to put it into here. So this is going to be 5. We then take away 1 from pointer. Because we take away 1 from pointer, this loop doesn't run again. I'm going to put into name this pointer plus 1, so into here for number 3, which is temp. So this is the number 3. So we've got 3, 5, 6. That is in order. Then what happens? This goes up by 1 again. Temp becomes 1. Pointer becomes this pointer, which is 4 minus 1, which is 3. Nice and easy. Oops. And then it does this loop again. Whilst name this pointer, which is 3, what's inside of it? 6 is greater than temp. It is greater than temp. And pointer is bigger than 0. Yes, it is. We're going to put name this pointer, which is 1, 2, 3, 6, and put it into pointer plus 1 here. So we're overwriting the 1 with a 6. We're then decrementing this value. So we've now got pointer being 2 It then loops again, name this pointer, which is now 2, which is 5. Is it greater than temp? Yes, it is. Temp is 1. So we're going to take name this pointer, which is 5, and put it into this position here. So we've got 3, 5, 5, 6 at the moment. Take away 1 from pointer. It's now looking at this one. Is this bigger than temp? Yes, it is bigger than temp. This is 3, temp is 1. So we're going to put 3 into here. We're going to take away 1 from pointer, which is going to be 0. It ends the loop. We put temp into name this pointer, which is 0 plus 1, which is 1. So we're putting temp into here. So here would be R1. And then it goes up again, so this pointer becomes 5, and I'm going to hold it there because the pattern just repeats itself in terms of how it works. So remember, the loop checks for this and it checks for this. So if the value isn't bigger than temp, so let's imagine temp is 8, which is the next one, and we've got 6 where it compares it to, it's not going to swap, so this loop doesn't actually activate. Okay, so let's just tidy this up. That would be the pseudocode. The Python code for this is basically the same. There's very little differences. One difference is we put it into a function where we're returning the array and we're passing in the array. Another difference is just the syntax for the loop. So for I, we're using this pointer still as our counting variable. So still this is a pointer in range 1 to the length of nameless, whereas this was 2 to 10. This will start still in here. Remember, in Python it'll be 0, 1, 2, 3, 4, 5, 6, 7, and we want to start in here. Why do we want to start here? Because we want to check it against the one before it. We're still using the temp. We're still using the pointer. We've still got the same loop rules. So all of this is the same.